Welcome back to Aurora Tech Channel. Today, I will review the Elegoo OrangeStorm Giga, which is the largest 3D printer I've ever seen, with an 800 by 800 by 1000mm print volume. It was a Kickstarter campaign a few months back. The Kickstarter price was $1,500, and the MSRP as of today is $2,500, not including shipping. The space required is around 50 by 55 by 65 inches, including the standard spool holder. The machine weighs over 200 pounds. The kinematics of this printer are Cartesian, similar to an Ender 5, but the print bed is fixed at the bottom. It consists of 4 print beds and 4 410 by 410mm textured PEI sheets, similar to those on the Neptune 4 Max. It has a total of 5 PSUs, one for the machine, including the motherboard, motion system, printhead, and screen, and 4 others, one for each print bed. When printing, the gantry moves up and down while the print stays on the print beds. The bed temperature can reach 90 degrees Celsius, which is good enough for PLA, TPU, and PETG, and I don't think anyone would expect to print ABS on this large open frame printer. The maximum nozzle temperature is 300 degrees Celsius, so you can still print nylon and polycarbonate. The extruder is a dual-gear direct drive, and the hot end has a longer heated block with a 60-watt ceramic heater. I can't see the exact flow rate of the hot end, but the slicer print profile limits it to 30 mm3 per second, so I assume the maximum flow rate is around that number. The part cooling fans are two 50-51 blowers installed on both sides of the print head. For the motion system, the X and Y axes use linear rails, and the dual Z axis uses 25mm dual linear rods and 16mm lead screws. The Y axis uses a NEMA 2355mm motor, and the X and dual Z axes use NEMA 1758mm stepper motors. There are 2 optical limit switches on the Z axis for gantry leveling, and the X and Y axes use mechanical limit switches. The bed leveling uses an inductive sensor, and there's an accelerometer inside the print head for input shaper calibration. Given the machine's tall Z height, it will also calibrate the input shaper at multiple heights. The motherboard is an MKS Pi OEM motherboard, so it most likely shares the same specs with a quad-core 1.5 GHz processor and 1 GB of RAM. The early version of the machine used 8 GB of eMMC, but Elegoo sent me a 32 GB one and also confirmed all new machines will come with 32 GB by default. The screen is a 7-inch touchscreen, and it hangs at the top of the frame. For the spool holder, it comes with a standard spool holder for smaller prints. However, when you want to print something tall or need to use a large spool of 3 kg or 5 kg filament, it has another set of on-the-floor or on-the-desk spool holders with bearings paired with a wheel with a filament sensor to provide smoother filament feeding. I will test both in this video. In the future, it will also support printing with 4 print heads at the same time, allowing you to print multiple copies of the same model simultaneously. I am excited to test this printer out and would like to thank Elegoo for sending us this machine and for sponsoring today's video. And with that, let's get started. The machine came in 2 huge boxes. The first box contains the base, the gantry, and some accessories. The second box contains 2 Z-axis frames, and the build of the machine looks no different than a regular 3D printer, except it's huge. We will start by putting the Z-axis on the left and right side of the machine. Then, use some corner brackets to reinforce the frame. Next, secure the top bars at the back and the front. After that, we can install the gantry on the Z-axis. We also bought a set of wheels for moving furniture to make this 200-pound machine movable. Then install the cable chain and the Z-limit switch trigger plates on both sides. Next, mount the print head, spool holder, and the screen. Finally, install 4 final corner brackets to secure the top frame. We can now move the printer back to our testing corner. Flip the power switch to match your local voltage. There are 5 switches, 1 for the main PSU and 4 for each print bed. Now the printer is ready to use, and the first thing we're going to do is try to level the bed as flat as possible before doing auto bed leveling. Go to Settings, Advanced Settings, and Platform Measurement. It will let you adjust 9 screws on each bed. and we will try to make every single point fall within a 0.05 to 0.1mm height difference. It came with 2 leveling plates, which are basically the same spring steel sheet without PEI coating, but with 9 holes for you to access the adjustment screws. You need to turn the screw just like how you turn the leveling knobs on a regular printer. You need to go back and forth to measure and adjust each point. After about 45 minutes, we made all 36 points at around 0.2mm, and the deviation is about 0.05mm, which should be good enough. Then, we can put back the PEI print surface and do a round of 100-point auto bed leveling. After that, it will pop up another screen for you to do the Z offset. Next, we can save all values and do input shaper calibration. The print head will shake to measure the frequency, and it's going to start from the bottom and calibrate the input shaper at 5 different heights. Okay, after 1 hour of assembly and another 1.5 hours for leveling and calibration, we can finally start our first print. I will just load in a large 3D benchy from the machine. The estimated time is about an hour. As you can see, my first try was unsuccessful. The Z offset was set too low and left a scratch on the bed. I have to use the screen to adjust it and restart the print. It looks much better this time, so I will let it print for a while and test the sound level. I'm about a foot away from the machine, and the sound level stays in the low to mid 60s in decibels. The print finishes in 1 hour and 9 minutes, which is slightly longer than the estimated time. The surface looks alright, but there is some filament residue that got into the body, and the retraction value is also not set too well, as I can see some imperfections on some layers. The other side looks better though, and the cooling is also okay. The Z offset value seems correct as the bottom stuck really well. However, the stock firmware has some issues with the Z offset as it won't save the value. I asked Elegoo and they told me they released a new firmware to fix this and some other issues. So, I will download the firmware and copy it to the USB drive to update the firmware on the eMMC of the motherboard. As you can see, the firmware version has been upgraded from 2.3.2.0 to 2.3.2.2. But we also need to update the screen. As the screen is working like a G-code sender, it has its own firmware like a Marlin touchscreen. You have to open the screen, copy the firmware to a micro SD card, and insert it to the card slot on the small PCB at the back of the screen. After the machine is on, you will see the screen firmware is also updating. Now both the machine firmware and screen firmware have been updated. After redoing auto leveling and input shaper calibration, we can continue with our benchmark test prints, starting with the number slider. The print finishes in 2 hours and 38 minutes, which is slightly slower than average new generation Clipper printers' print time of 2 hours to 2 hours and 15 minutes. The actual time is also longer than the estimated time in Cura. The top is a tiny bit of stringing, but the back looks perfect with good clearance. All tiles can move freely. Up next, I will test the tolerance and see if the parts can fit well with each other. I will print my own simple geometric model. The The print finishes in 2 hours and 6 minutes, and the speed is in line with other new generation printers, but it's still slower than the Cura estimated time of 1 hour and 40 minutes. Let's test the tolerance. For the square, it can clear all the way from 0.225mm to the tightest 0.05mm, which is the perfect score. For the cylinder, it can also clear all the way from 0.225mm to 0.05mm, so other than some ringing on the surface, the tolerance test is very good. Then, I would test the retraction of the extruder by printing the Honeycomb box. This time, I would try to print it on the back left plate. As you can see, it heated up 2 beds as the purge line was printed on the first bed. The firmware will only heat up the beds that you're printing with. The purge line also counts, but we can manually turn off a bed after the print is started. The extruder can handle these tiny honeycomb patterns pretty well. The print finishes in 1 hour and 57 minutes, which is in line with other new generation printers. There is some stringing, but all the honeycomb can be printed without any broken patterns. Let's compare it to the same model printed by other machines. This print made by this huge machine is not the best, but I think it is still slightly better than average. Before we move on to print some large prints, I also want to print the Robo Alpaka to test the surface quality. Surprisingly, this print is slow. It took almost 8 hours, while most new generation printers take around 4.5 hours. I think the reason behind this is the body of this model has quite a lot of room for acceleration, but the firmware limits the acceleration to 5,000 mm per second squared, while other new generation printers can reach 10K or even 20K for infill, resulting in the printing time taking much longer. Let's take a look from all 4 angles. The surface quality looks pretty good, but let's see how it compares to other printers. Compared to the Elegoo Neptune 4 Max, the print quality is similar. The OrangeStorm Giga may be slightly better, but the printing time is much slower. Compared to the Ender 3 V3 Plus, a mid-sized bed slinger, the OrangeStorm Giga surface quality is better, but the speed is much slower. Compared with the standard-sized bed slinger, the Cobra 3, the Cobra 3 surface quality is better and also faster. When compared to the Prusa XL, the XL is not fast, but it's still faster than the OrangeStorm Giga, and the surface quality of the XL is a clear winner. When compared to the K1C, the K1C with the Core XY kinematic and box frame wins for both surface quality and print speed. I think the surface quality of OrangeStorm Giga is acceptable, and it's slightly better than larger bed slingers, but it's not as good as regular bed slingers and Core XY machines. As no one expects to buy a printer at this size just to print regular size models, I will start printing some large models. The good thing is it came with 4 spare nozzles from 0.4 to 1mm. I will switch to the 1mm one and see what kind of results we can get. I will first print a Master Sword from Zelda to use up all 4 print beds. When all beds are heated up from room temperature, it draws over 1700 watts from the wall. I just gave it a separated power cord without anything else sharing the 15 amp breaker. It almost maxed out the breaker, but it'll only last for a few minutes. After the bed reaches the printing temperature, it only draws around 400 to 700 watts most of the time. It now starts printing the first layer, and it seems the print sticks pretty well on all 4 beds. The actual speed is quite slow, as the hot end flow rate is around 30 mm3 per second. When using a 1mm nozzle with a 0.8mm layer height, the maximum speed the hot end can handle is 37.5 mm per second, and the default slicer profile is set to 30 mm per second, which seems reasonable. As for printing with a large diameter nozzle, even when printing at just 30mm per second, this large print can still be done in 5 hours and 21 minutes. When printing at a slower speed, the Cura estimated time is pretty accurate. The print stuck pretty well to the bed. There is some stringing, and the print quality of using a 1mm nozzle clearly can't compare to a regular 0.4mm nozzle. When the model is crossing multiple beds, you will see a stitch mark, but it's not too obvious. After gluing both pieces together, I think this 5-hour master sword still looks pretty cool. Then, I would try a tall print to max out the Z height. When printing a tall print, you can't use the spool holder that is attached to the back of the printer, as when the Z height comes close to the top, especially when your print is at the far corners, the extruder is going to pull the filament at a steep angle that would probably cause under-extrusion. So, this printer came with another spool holder and a wheel for large spool and tall prints. However, when I try to use it with a 3kg cardboard spool of PLA, as the edges of the cardboard are deformed due to the over-tight vacuum packaging, it doesn't work well on this roller-type spool holder. So, I will design a simple spool hanger and print it using PETG with the same 1mm nozzle. Even when printing at 30mm per minute, it just took less than 2 hours. As a functional part, it looks fine, and even the 0.8mm layers are much thicker than a normal 0.2mm layer height. It feels more rigid and works just fine as a spool holder. I will use some aluminum extrusions for a heavier base. As you can see, when the filament sensor is placed behind the wheel, it won't increase the tension even when the Z height reaches the top. I will now print this Oscar trophy. When I try to set the Z height to 1000mm, the slicer won't let me do that, so I just set it to 999mm. This print is going to take almost 30 hours. Let's send it over the network and see how it does. It was printing fine for over 25 hours straight, but when it ran out of filament, the print didn't pause. I won't blame the machine as I forgot to connect the filament sensor cable. The model is now 80% done, so I definitely won't waste another 3 kilograms of filament to print another one. As the screen stated, it printed 1003 out of 1243 layers. I will estimate the height of the remaining model, try to slice the top part and print it again. It already printed a few layers in the air, but I will just try my best guess and see if I can fix the model. I spent another 4 hours printing this part, but it's still missing around 4 layers in the middle, so I just moved it a bit higher and manually edited the G-code to just print 4 layers to fill the gap. After gluing all 3 pieces together, it doesn't look too bad. When zoomed in really close, you can see some imperfection, but overall, it is still better than wasting another 3.5 kilograms of filament to reprint this model. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The frame is rigid. It's much heavier than I expected, and the whole machine weighs over 200 pounds, making it very sturdy. We actually had to buy some furniture moving wheels to be able to move it around. The metal base, linear rods, and lead screws on the Z-axis are the thickest I've ever seen. 2. It calibrates the input shaper at 5 different heights. I think this part makes a lot of sense, as the vibration is going to increase when the Z height increases. It does require different sets of values to properly compensate. Unlike most printers with a tall gantry that only calibrate input shaper at the bottom, I think this machine did a really good job. The linear advance was also well calibrated, as the tolerance test went perfectly. 3. By using 4 individual print beds and textured PEI sheets, it saves money and works well. For the master sort I printed, which used up all 4 beds, the stitch marks are minimal and it didn't bother me at all. 4. Assembling the machine is fairly easy, as the printer is just a pumped up version of a box frame under 5. If you have the physical strength, you could definitely just put it together like a regular 3D printer. 5. The extra filament wheel works. When using the stock spool holder mounted at the back, it's fine for shorter prints, but when the Z-axis reaches the top, it's going to pull the filament at a steep angle, and that's where the wheel comes into play. The wheel itself can turn a certain amount of degrees that covers the entire printing area. The filament sensors also put at the back, so it doesn't create any extra tension or friction. The wheel allows the filament to feed in smoothly even at the top. 6. It has 2 optical limit switches for gantry alignment. Every time you home the printer, these 2 limit switches make sure the gantry is level, but I will talk more about this in the cons section. Now for the cons. 1. The Z offset is a bit strange. When you set the Z offset using the leveling menu, the value is based on the difference between the nozzle height and the optical limit switches. So every time the printer starts, you see a base Z offset plus another adjustment value, which is a little confusing. I think it would be better to level the gantry before homing using the optical limit switches, but the actual Z homing should use the inductive sensor. That way there would be only one Z offset value, making things simpler. 2. The maximum flow rate of this hot end is set to 30 mm³ per second, which isn't bad, as most of the latest fast printers I've tested are between 20 to 35 mm³ per second. However, since it has a huge print volume, when I was printing with a 1mm diameter nozzle and a 0.8mm layer height, the maximum speed you can reach is just around 37.5 mm per second. So, Elegoo could consider releasing a hot end upgrade that can boost the flow rate to ideally over 100 mm³ per second to unleash the power of this machine. Otherwise, the speed simply can't increase, as the hot end can't melt the filament fast enough. 3. The Wi-Fi isn't working well enough. The antenna is covered by the metal base, and even though my router is in the same garage that I'm printing in, the Wi-Fi signal is weak. I have to disconnect and reconnect it a few times to make it work. Unless Elegoo can add an external antenna, it would be better to use an Ethernet connection or just copy the file to a USB drive. 4. The USB drive is located at the bottom, which makes sense since the motherboard is there. However, it would be better to have an extension cable so the user can access the USB drive somewhere at the top, or simply allow the USB drive to be plugged into the screen. In conclusion, the value of this machine is pretty good. The hardware is solid, and the frame is rigid, weighing over 200 pounds. The best part is the huge print volume. When I first started testing the printer with the stock firmware, I found some errors in the screen menu, especially with Z offset confusion, as the updated Z offset value couldn't be saved without redoing the 100-point bed leveling. After the latest firmware and screen firmware updates, it seems most issues have been fixed. As you can see, there's only one deep scratch on the print bed from the first benchy, but the rest of my prints turned out just fine. I believe Elegoo made a lot of efforts to fix the firmware glitches, and they also improved other small details, such as the new spool holder to provide smoother feeding. The eMMC has also been upgraded from 8GB to 32GB. Now, I can say this printer is fully functional like all other regular-sized 3D printers, just with a slower print speed and acceleration. Using a 1mm diameter nozzle to print larger objects is fun though. While the print quality with a large diameter nozzle is not the best, it is still decent. This machine has a lot of potential, especially if Elegoo releases a high-flow hot end in the future. This printer is one of a kind, and it has no direct competitor in the market. The Kickstarter price of $1,500 was an awesome deal, while the normal MSRP is $2,500, which is still reasonable. Normally, after the Kickstarter campaign, the actual price to get the printer is somewhere between the Kickstarter price and the MSRP, so I'm guessing you may still be able to get this printer for around $2,000 plus shipping. If you are interested, I included a link to this machine in the description, as well as a link to my website auroratechchannel.com, which tracks prices for over 150 popular 3D printers, laser engravers, and CNC machines. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.